Okay, so today we are going to discuss about the dimensions. So first of all, dimensions. Dimensions are basically the way to describe about the physical quantities of object and phenomena. Way to define physical properties of object and phenomena. Okay, so here we have three major dimensions. Before starting that, let me teach you about the dimensional analysis. What dimensional analysis? What is dimensional analysis? These are basically those physical quantities in terms of which it can be represented in power. ऐसी physical quantities, those physical quantities in terms of which जिनको हम रिप्रेजेंट करें इन पावर वी ऑल नो. तो डायमेंशन एनालिसिस वो कहते हैं कि ऐसी फिजिकल क्वांटिटीज़ जिनको हम रिप्रेजेंट करें किसकी फॉर्म में, पावर की फॉर्म में. ओके, सो नाउ हियर वी हैव डायमेंशनल वेरिएबल. जल्दी ये डायमेंशन एनालिसिस याद कर लो. नाउ वी हैव डायमेंशनल वेरिएबल. अब इस डायमेंशनल वेरिएबल में बस क्या होता है, दोज फिजिकल क्वांटिटीज विच आर वेरिएबल एंड येट हैव अ डायामीटर. ऐसी क्वांटिटीज जो वेरिएबल है और इनके पास डायामीटर भी है. दोज फिजिकल क्वांटिटीज have variable are variable and have diameter. ओके, सो डायमेंशनल वेरिएबल क्या है, ऐसी फिजिकल क्वांटिटी जो कि हैं तो वेरिएबल लेकिन उनके पास फिर भी डायामीटर है. तो ये देखते हैं कौन कौन सी हैं. तो वो हमारे पास मेजर थ्री मेजर वी हैव मास, लेंथ, टाइम. अब हमें डायमेंशनल अगर हम पढ़ते हैं तो हम मास को डिनोट करते हैं m, लेंथ l, टाइम t. अब हम इसकी बेसिस पे सारी डायमेंशन बनाएंगे. Okay, so let's discuss. First, number one is area. Okay, so now here we have area. So for the area for the sheet, we have rectangular sheet for that area. So first of all, we all know that what is the formula of area. So that is length multiplied by width. Okay, so here the length unit is meter and width unit is meter square, so is equal to L square, as L is what, physical quantity and its unit is meter. So area, maybe it's clear to you. Now we will find out now let's find volume. Okay, so volume of the cube. For cube we have formula that is length multiplied by breadth multiplied by height. So is equal to meter multiplied by meter. These all three quantities we have meter unit. So meter is equal to meter cube. So is equal to length cube. Okay, so now let me teach you about the volume of a sphere. volume of sphere. Okay, so volume of sphere is basically like for the sphere we know the formula, that is 4/3 pi r cube. This is the formula. And here for the volume we have what? Unit is meter cube, so is equal to length cube. Okay, so now we have the fourth one, that is speed. What we have? Speed. Okay, so the formula of speed is basically distance traveled upon time taken. For the distance we have meter, for the time we have second, so is equal to meter, and when second will come up we have the negative sign, that is -1. So this is and here leave this meter. Meter is the what? Unit of length, second is the unit of time, so this is LT -1. Okay, now we have fifth one, that is acceleration. So for the acceleration we have formula, we have the velocity, rate of change of velocity upon time taken, change in velocity upon time. So for the velocity we have meter, and for meter per second, okay, and meter per second. Then for the time we have second, so equal to second square, meter per second square. For the meter we have length, and for the time we have t square, so equal to LT minus 2. Hopefully you are getting this. Okay, now let me teach you some more dimensions. Okay, so after acceleration we have linear momentum. For the linear momentum we have formula, that is kilogram meter per second. So for the kilogram we have m, for the meter we have L, for the second we have t, so that will be MLT -1. Okay, for the kilogram, m, meter, length, second, time. And for number 7 one we have force, and the force is equal to ma. Okay, so here formula, kilogram meter per second square, so kilogram m, meter length, second t 2, equal to MLT -2. Okay, now we have 8th one, that is torque, and the formula of torque is force and r vector. So here force Newton meter, and Newton meter is basically unit of kilogram meter per second, Newton kilogram meter per second, then we have meter dot meter, as Newton is equal to kilogram meter per second and meter. So here we have kilogram m, meter L dot L t second. So again here we have, let me write here, m L square t -1. Okay, and after that I will tell you something more about that, but let me go through that. 9 when we have power, and the formula of power is F multiplied by V. So here for the we have Newton meter per second, force Newton, velocity meter second, and for Newton meter we have joule per second, and joule, and now Newton is equal to kilogram and dot meter square and second cube. Now see how I did that. Here we have Newton, and the Newton is basically kilogram meter per second. What Newton is? Kilogram meter per second. After that down we have second again, and here we have meter again. So here you can see kilogram, meter, meter square, second square. Then we will add these, as joule is equal to meter, so joule will cut, and here we will add second one, so that is kilogram meter per second upon second cube. Now the dimension of this is kilogram meter, kilogram we have mass, then we have L2, then we have T minus 3. Okay, now we have another one, that is angular momentum. So for the angular momentum we have formula, that is length is equal to P multiplied by R vector. So as we have formula, that is kilogram meter dot meter upon second. So here we have kilogram meter square upon second. So in the dimension form, kilogram ml2 t minus 1. This is dimension. Now we have 11 frequency. For frequency we have hertz. Unit is hertz, and the formula is 1 upon t. Okay, so here 1 upon t is equal to t minus 1. Simple. Now we have pressure. Pressure we have P is equal to Newton upon A, and this is Pascal, and Newton. Area we have meter square, so that is Newton we will write that in kilogram. Newton is equal to kilogram meter per second. Okay, so here kilogram m, then L minus 1, then we have the second, then T, and that is minus 2. Okay, hopefully it is clear to you. Now third one, last one, power of length. As we have formula P is equal to 1 upon F, so the dimension will be m L T minus 1 minus 2 2. This is the dimension. Hopefully the dimensions are clear to you. Now let me tell you some more points, that the dimension of speed, like speed, this is dimension, is equal to velocity, same as velocity. And here we have what? Acceleration. Acceleration is dimension is same as gravity. Linear momentum dimension is same as impulse. Okay, force dimension is same as weight. Torque dimension is same as work or different form of energy. Power dimension is same as radiant force. Angular momentum dimension is same as Planck's constant. Frequency dimension is same as angular velocity. So these are basic dimensions. Hope you got it. Bye bye.